Now we've talked about how to do unsigned numbers, let's start talking about how to do signed numbers. So we're going to start out talking about a technique called signed magnitude. And this is the obvious, but also the wrong way to represent signed numbers. We'll talk about how it works and give you some examples of why it's not really the right way to do it. So in general, there are three ways to represent signed numbers in computers. You could probably come up with others, but these are the ones people typically talk about. Signed magnitude, this is the simple one that we're going to talk about now. One's complement, that nobody really uses, and two's complement, which is what everybody actually uses for signed numbers. So we're going to start out going through signed magnitude because it's simple, and I want you to see why it doesn't work so well. And then later we're going to talk about two's complement in a lot of detail because that's what everybody uses. So in all three of these representations, the MSB, or the most significant bit, is also the sign bit. That means if the most significant bit is 1, all of these numbers are going to be negative. If it's 0, they're positive. So no one uses 1's complement, as I said, so we're going to skip it. Everyone uses 2's complement, that's what we're going to talk about next. But signed magnitude is also used in a few cases, so we'll see it again when we talk about floating point numbers. So let's see what signed magnitude is. It's a really simple idea. We're going to use the first bit to indicate whether a number is positive or negative. So here are a bunch of numbers. The first bit is 0, so these are all going to be positive. And here the first bit is 1, so these are all going to be negative. So we have some problems here. First of all, we have two zeros. We have positive 0 and negative 0. And that's not really great. It means if we want to check if something's 0, we have to check for either case. As you note here, here's the most significant bit, and this is the sign bit. So it tells you whether it's positive or negative. And that's going to be the case for all of the formats we look at. So why is this a problem? So the problem with signed magnitude is we have to take care of the sign and the magnitude separately. So for example, if A is negative and B is negative, then A plus B is just negative A plus B. But if A is positive and B is positive, then A plus B is now positive A plus B. So now we have to do a different addition operation depending on whether A and B are negative or positive. So that's a hassle. And it's a lot more messy for subtraction. So if we're going to do A minus B, well, if A is greater than B, then it's just A minus B. But if A is less than B, then the result is negative B minus A. So now we have to do something different depending on whether A is greater than B or less than B. So this gets really messy. And you can look at other examples which are similarly messy. So what you have for signed magnitude is you have all these special cases depending on the sign. This is ugly and it's slow, and so we don't use it. So what we're going to talk about next is what we do use everywhere, which is two's complement. And the wonderful thing about two's complement is it makes both subtraction and addition the same. So you do the same operation regardless of the magnitude or sizes of the two things you're working with. And that's why two's complement is what we use.